This section explains what it means to crunch knowledge and why a domain model is built rather than handed over. The intuition is that an expert pours knowledge into a developer. That picture is wrong. A domain model gets compressed together by expert and developer at once. Evans opens with the printed circuit board story. Asked what the software should do, the circuit experts answer with an ASCII sort and report, which is useless. The real value hides in their vocabulary, the words net, pin, hop, and push. The developer diagrams those words, misdraws them, gets corrected, and redraws. The model is the fixed point of that correction loop, and it is selective. Topology gets dropped the instant it stops serving the probe simulation. So a model is a task-tuned, lossy encoding of the domain, refined until it runs as code, one object shared by the expert, the diagram, and the Java. Knowledge-crunching names, the ongoing search for that minimal, executable model. It is never a phase that ends. This section explains why a domain model is the medium of understanding, not a record of it. A domain model is not documentation distilled after you already understand a field. It is the medium in which the understanding happens, and it stays honest only by being bound to running code. Chapter 1 opens the book by collapsing 3 activities into one feedback loop. Talk sharpens the model disciplines the code, the prototype's behavior corrects the talk. The printed circuit board probe, simulation dialog is the anchor. The terms net, push, and hop emerge together, and the term topology is dropped the instant it earns nothing. Backdropping is the thesis. Crunching is compression, winnowing a torrent of facts down to the few abstractions that generate the rest. Every later mechanism, the ubiquitous language and the bounded contexts, exists to keep this loop tight. This section explains the ubiquitous language, the structural primitive underneath communication, and the use of language in domain-driven design. Start with the pathology it kills, translation. A single language is spoken everywhere, the same terms in the domain expert's mouth, in the UML box, in the method name. Every dialect boundary a team crosses leaks, meaning expert to developer, developer to developer, speech to code. Each of those leaks hides a schism no one notices. The ubiquitous language fuses the dialects into one carrier. Its words name the model's classes, and its grammar is the model's relations, so speaking the language exercises the model itself. Here is the turn that surprises. You do not perfect the language first, and then use it. Relentless use is what forces the model's flaws open, and renaming a term edits the model itself. The cargo router dialogues stage exactly this gap, deleting rows in a table on one side versus what the reroute actually means to the business on the other. This section explains the ubiquitous language, the second structural primitive. One language spoken everywhere is cheaper than any translation between two. That is the whole move. Collapse the domain expert's jargon and the developer's design talk into a single ubiquitous language whose vocabulary is the model's classes and operations and whose grammar is the model's relationships. Every translation layer leaks. Schisms form silently and knowledge crunching goes anemic. So the fix is not a better translator. The fix is the elimination of the seam itself. The structural consequence follows by fixed point. The language is the model, so changing a word changes the model and the code renames to match. The two cargo router dialogues anchor this. same problem, and only the pair who share the terms, route specification and itinerary, can actually reason about it. This section explains the third structural primitive, binding the model to the implementation. A model on paper that the code ignores is worthless. Two models, one for analysts to understand and one for developers to build, guarantee exactly that fate. Insight bleeds out at the handoff and never crosses back. Model-driven design collapses the dichotomy. Seek a single model that serves analysis and implementation at once, so each object in the design carries a conceptual role and the code becomes an expression of the model. The astrolabe is Evans' anchor, a mechanical implementation of a model of the sky. The math made literally operational. The generative move is this: reject any abstraction that cannot run, and reject any implementation that explains nothing. Iterate until one representation binds both. This section explains the core demand of Evans' chapter on model-driven design. A model on paper that no code obeys is worthless. A code base with no model beneath it is a mechanism that acts without explaining itself. Evans collapses the two into one demand, a single model that is at once the domain's truth and the design skeleton. The astrolabe carries this: the brass instrument is itself the model of the sky, a working embodiment rather than a depiction of it. So refuse the split between the analyst's model and the designer's model that most methodologies bless. When a model resists implementation, discard it. When it betrays the domain, discard it. Code becomes the model's literal expression, which means editing the code edits the model. The two can no longer drift because they are one artifact. This section explains how a domain model becomes thinkable by isolating it into its own layer. A model becomes thinkable only once you can see its objects as a system, instead of picking them out of the whole program one by one, like identifying constellations in the night sky. That is the whole move. Domain logic diffused through the user interface, persistence, and orchestration cannot be reasoned about. So you partition the program into layers that depend only downward, and you concentrate every domain concept in one isolated domain layer. The four canonical layers are a convention. Domain-driven design strictly requires only that one layer, the domain layer, to exist. The generative test is the boundary. The smart UI, where the business rules live inside the interface itself, is the deliberate fork where you refuse isolation. It is legitimate for simple data entry work, but it is a road with no graceful path to richer behavior. This section explains the four-layer separation and why only one of the four boundaries actually matters. The model can only be reasoned about as a system when nothing else shares its space. So concentrate every domain concept into one layer and forbid it from knowing about the layers that display, coordinate, or persist it. That is the whole move, partition by concern and let dependencies point only downward. The domain then floats free of the UI, the application, and let dependencies point only downward. Evans' four layers are convention, but the piece that carries the design is the domain layer's isolation alone. It is the single layer that domain-driven design actually requires. The boundary is taught best by its negation. The smart UI, meaning business rules welded into the widgets, is a coherent choice for simple data entry work and a dead end for a rich model, because there is no graceful path from one to the other. This section explains why, in domain-driven design, every implementation choice is also a modeling choice. That claim is the whole chapter, and every building block is a corollary of it. Here is the pattern to carry forward. Sort each domain element by one question. Does it have identity, or is it pure description, or is it an operation? Those three answers yield the three building blocks: the entity, the value object, and the service. Modules are the same sorting applied to concepts rather than to objects. The surprising part sits in the associations. Take a bidirectional link between a country and its president and constrain it to a single direction. That constraint looks like a concession to the compiler, and its real content is semantic. Choosing one direction records that one direction is the one that carries the meaning. Two more consequences. Close the chapter. Simplifying the design and deepening the model are the same act, and the building blocks exist for one reason: so the domain survives contact with the database. This section explains how every element in a domain model sorts into one of three kinds, decided by a single question: what survives change? An entity carries an identity that persists while its attributes mutate. It is tracked across states, equal to itself alone. A value object has no identity. It is its attributes, interchangeable with any copy that matches. A service holds no state at all, a stateless operation done on request, standing in for the domain. Verb that no noun should on. The classification is behavioral. You sort each element by what persists under mutation, never by the fields it lists. The same move disciplines associations, impose a direction, add a qualifier, delete the inessential, until each relationship carries the domain's own bias. This section explains the life cycle of a domain object and why the right unit to protect is a boundary rather than a single object. An object persists, mutates, and dies. Once references tangle, consistency can no longer be defended, object by object. The generative move is this: draw one boundary, the aggregate, around whatever must stay mutually consistent, expose a single root entity as the only external handle, and let every invariant live inside it. The life cycle then reduces to crossings of that boundary. A factory handles birth, assembling the whole object atomically with its internals encapsulated. A repository handles the long middle and retrieval, hiding the persistence machinery behind a domain-shaped query. The chapter's work is placing a guardian at the boundary for each transition that could break an invariant. Predict the rest. No rule ever guards a lone object. Always a boundary. This path explains why domain-driven design must declare an aggregate boundary, and how the factory and repository serve its two lifecycle crossings. An object graph has no natural edges. Delete a person, and does the shared address go with it? Yet, transactional consistency demands edges. The chapter's single move is to declare the boundary the domain refuses to give you. An aggregate names one root, entity as the sole handle outsiders may hold. Invariants hold inside it at every transaction, and across it only eventually. Once the boundary exists, its two life cycle crossings each get a construct built for that crossing alone. The factory makes birth atomic. The repository makes retrieval a query. This is infrastructure that would otherwise smear across the model, encapsulated exactly at the seam it touches. Draw the boundary first, then delegate every transition across it. This section explains how the design patterns behave when you stop teaching them in isolation and run them together on a single domain. Patterns taught one at a time lie about how they are actually used. This chapter's whole work is to run them together on one domain, the cargo shipping system, and watch them compose. The forcing function is implementation. You hold the domain insight fixed and refine the model only until it materializes in code. Watch the moves. Layered architecture carves off a domain layer. Then every object meets one question. Does it carry identity to track, making it an entity, or is it a shareable value, making it a value object? Customer and cargo are easy entities. Delivery specification is a value. Delivery specification is a value. Delivery specification is a value. Delivery history is the tricky borrowed identity case. The primitive is this. Translation into code is itself the refinement pressure, and a model survives it only if you can still speak it. This section explains why the building blocks chapter exists and the primitive it hands you. The 3 preceding chapters handed you patterns, one at a time. This chapter's whole reason for being is that a real design never applies them one at a time. Evans runs a single cargo shipping model through a succession of refinements. He layers off the domain, splits entities from value objects, and folds the delivery goal into a delivery specification. Every move is forced by one pressure only, keeping the model and the running code the same object. Here is the primitive to carry. The building blocks are a language, and a language shows its grammar only in composition, never in isolated words. What looks like a checklist in Part 2 is really a set of forces that resolve each other on contact with one concrete domain. This section explains why refactoring pays off in chunks rather than a smooth line. Refactoring's returns are nonlinear. Small refinements pay marginal, additive gains until accumulated clarity crosses a threshold and the model reorganizes discontinuously. Explanatory power jumps while complexity evaporates. That shape is a phase transition, not a technique. The order parameter is understanding, building quietly until the jump fires on its own. Evans anchors this in the share pie. 2 concepts, investment and loan. Investment collapse into one concept, shares, dissolving an inappropriate constraint and all the special case logic propping it up. The tell that you are near one is complexity climbing faster than functionality, small fixes never converging. You cannot schedule the breakthrough. You cultivate its precursors, knowledge crunching, and a supple, ubiquitous language, and you stay watchful when the crossing arrives. This section explains why refactoring reaches a breakthrough as a sudden event rather than a smooth gain. Refactoring pays back linearly until it doesn't. The chapter's thesis is a phase transition. Small model refinements accumulate as latent stress against a wrong abstraction, and past a threshold, the domain suddenly reorganizes, complexity evaporates, and explanatory power jumps. The syndicated loan story anchors this. Months of patching loan, adjustments onto a model that wrongly welded facility shares to loan shares until the team sees that both were special cases of one concept, the share pie, and the special case logic dissolves. The breakthrough, as Chapter 8 puts it, is not a technique. It is an event. You cannot schedule it. You can only recognize it and choose to rebuild. Here is the recognizable signature. Predict the adjacent case. The deeper model arrives feeling not triumphant, but frightening, because it demands rewriting working code. This section explains how to make an implicit concept explicit. A domain concept can be fully operative in your system, yet have no name inside it. The data is assembled, the behavior scattered across a report in a database query, but no object denotes the thing itself. The move is reification, promote that implicit pattern to a first-class object carrying its own name. Evans' anchor is the shipping itinerary. Every attribute was already present. its logic buried inside an itinerary report, until naming it collapsed the scatter into one denotation and paid off in 6 ways at once. An expressive service interface, decoupling from the database, killed duplication, and an expanded shared vocabulary. The generative test is one question, what already runs everywhere but is named nowhere. Language, design awkwardness, and expert contradiction are the channels that surface it. This part explains the reification signal and how a missing object announces itself. A word the domain experts say fluently that your design cannot name is a missing object announcing itself. That gap, vocabulary alive in speech but absent from code, is the reification signal. You close it by promoting the implicit concept to an explicit model element. The itinerary was already there, scattered across a database table and a printed report doing its work silently. Naming it as one object decoupled the routing engine, killed the duplication, and sharpened every conversation after. The move generalizes past the idea that nouns are objects. Hunt the awkward procedure, the term that draws puzzled looks when you fumble it, the contradiction between two experts. Each one marks a concept the model has not yet made speakable. This section explains what makes a design supple and why suppleness is the discipline that keeps change cheap. A design has 2 users, and only one of them is the machine. The other is the next developer who has to read it and recombine it. The chapter's move is to judge a model not by the behavior it runs today, but by what it costs that next developer to reassemble it. Under that judgment, the interface becomes the whole object. Under that judgment, the interface becomes the whole object. Suppleness means that change stays cheap, even as behavior grows rich. Stiffness is the opposite ceiling, the point where fear of some unforeseen dependency stops the refactoring, and complexity wins. Suppleness is the complement to deep modeling. First, you dig out the implicit concept, the work of the prior chapter. Then, you hammer it into a shape a client can flexibly assemble. The false path here is flexibility, bought through layers of abstraction. Those layers get in the way. The real target is simple, and simple is not easy. This section explains why a design becomes changeable and what makes it so. A design becomes changeable exactly when its surface stops making you read its insides. Evans' claim in Chapter 10 inverts the usual order. Software serves users, but first it serves the developer who must recombine it, and the ceiling on how rich the behavior can grow is set by how afraid that developer is to touch it. Suppleness is the complement to deep modeling. Once the implicit concepts are explicit, you shape the surface so change bends at the model's joints, and every consequence is predictable from the outside. The patterns, intention, revealing interfaces, side effect-free functions, and assertions are all one move. Push the tricky mechanism behind a name that states intent never means. This section explains what it means to apply an analysis pattern. An analysis pattern is a borrowed starting point, never a finished answer. Someone else already paid the trial and error cost of modeling accounts, entries, and conservation. Evans' chapter says to graft their result onto your domain to skip the expensive search and then immediately refactor away whatever domain to skip the expensive search and then immediately refactor away whatever does not. The dialogue about account, entry, and transaction is the whole lesson in miniature. The developers adopt Fowler's model, and the payoff turns out to be rejecting transaction because their accruals do not move money in a closed system while keeping the concept of accrual that the expert hands them. The pattern is compressed, experience, model insight plus design consequences reused rather than applied. Its worth is measured by how much good structure survives your refactoring, not by fidelity to the diagram. This section explains what an analysis pattern is and how you actually use one. Someone already made your modeling mistakes. An analysis pattern is their scarred experience handed forward as a reusable model fragment, a seed you grow from, rather than a finished solution you drop in. This is Evans's thesis, carried by the two accounting dialogues that mine Fowler. You do not install the pattern, you refactor from it. What survives that refactor is the abstracted vocabulary and the warnings about downstream consequences. The diagram itself does not survive. The developers diverge hard from the book's transaction and method, yet keep the essence. That is the move. Structurally, this is knowledge reuse, categorically distinct from code reuse. A framework is a working whole. An analysis is a kit of fragments feeding the knowledge, crunching loop. This section explains when a design pattern stops being a coding trick and starts being a statement about the problem itself. The same object graph can be read at two altitudes. Down in the code, it solves a technical problem. Up in the model, it means something a domain expert already believes. A Gang of Four pattern earns promotion to a domain pattern only when its shape is isomorphic to a concept in the problem space. Strategy becomes an actual business policy, the leg magnitude choosing roots. Composite becomes a root genuinely made of roots. The discriminating test is erasure. Strip away the implementation, motivation. Then ask whether the pattern still asserts something about the domain. Flyweight fails this test. It is pure object. Sharing bookkeeping with no conceptual referent, so it never crosses over. A pattern is domain-worthy exactly when it survives the removal of its own cleverness. This section explains when a design pattern earns a second life as a domain pattern. That crossing happens when the pattern structure carries meaning on two levels at once, the technical mechanism in the code and a concept the domain expert would recognize in the model. The test is denotation. The pattern crosses over only when its structure actually denotes something in the domain. Convenience alone does not qualify it. Strategy crosses object count, saying nothing about the domain. The domancy algorithm is an actual business policy, as in a routing choice between cheapest and fastest, a choice of leg magnitude. Composite crosses only when a true whole-part hierarchy exists, as in a root made of roots. Flyweight never crosses. It optimizes object count, saying nothing about the domain. So the Chakta's move is this. Inherit the Gang of Four's accumulated implementation wisdom. Then add the layer of conceptual meaning that makes the same code speak the domain's language. This section explains how Chapter 13 redefines what refactoring is optimizing for. Conventional refactoring minimizes an objective defined on the code itself: coupling, duplication, awkwardness. That objective has a smooth gradient, so you can descend it by small local steps. This chapter replaces the objective entirely. The new quantity to minimize is the distance between the model and the domain, sensed through whether the ubiquitous language still binds the model and the domain still binds the developer and the expert. The trigger changes with the objective. It is no longer ugly code. It is a word that has quietly stopped meaning the same thing on both sides of that conversation. The descent changes too. It is not a smooth gradient, but punctuated equilibrium, which is Evans's own anchor for it. Long stretches of steady refinement are broken by a sudden insight that exposes the old model as poor and plunges through to a deeper one. Refactoring here is epistemic rather than cosmetic. The fixed point it converges toward is a truer model, not tidier code. This part contrasts ordinary refactoring with the kind that reshapes a domain model. Ordinary refactoring holds behavior fixed and improves the code. This holds the domain fixed and improves the model. The invariant shifts from preserving output to fitting the expert's language. The trigger for refactoring is a design that has stopped expressing the team's current understanding rather than code that merely looks ugly. The motion is not steady. Evans borrows the idea of punctuated equilibrium, the challenge to Darwin's gradualism that displaced it in the 1970s. Long stretches of micro-refinement are interrupted by a breakthrough where the whole model reorganizes. It is felt as crisis, because you now see the old model from a higher vantage. The generative move is to read awkward code as a symptom of a missing concept, and to let insight trigger the change, rather than tidiness. This section explains why a single model spanning a whole enterprise is the seductive wrong goal, and how integrity is actually bought. The opening. Charge story shows the failure. Two teams silently reused, one object under contradictory meanings, billing customers on one side, paying vendors on the other. Once the code merged, the model corrupted itself. The primitive is this. Consistency is a local property to scope, not a global one to enforce. A model's terms stay unambiguous only inside a drawn boundary. Nothing crossing that boundary is free. Every crossing is an explicit, chosen translation. Integrity comes from naming where each model reigns and how neighbors relate, rather than from unifying everything. Total unification costs more than it returns. The win is making the seams conscious. This section explains why a model's terms only stay coherent inside a boundary you draw on purpose. A model's terms mean one thing only inside a boundary you draw on purpose. The spine of the chapter is unification, every term unambiguous, no rule contradicting another. That kind of unification is achievable locally, never across a whole enterprise, so stop trying for it globally. The opening example, the charge collision, is the whole argument in one anchor. Two teams reused a class with the same name, and each meant something different by it. One team meant billing a customer, the other meant paying a vendor. The contradiction stayed silent until it surfaced as crashing tax reports. The fix was a bounded context, an explicit membrane like a cell wall, declaring where this model applies and where translation begins. A better shared model was the wrong instinct. The right structure is the boundary itself. Consistency is a property you scope and defend. Treating it as something you can assume everywhere at once is the mistake. Integration across boundaries costs translation, and that cost is the price of coherence. This section explains distillation, the strategic move that concentrates your effort onto the part of a design that actually matters. Not all of a design carries equal worth, so treating it as uniform squanders your scarcest resource, skilled attention on the parts anyone could build. Evans' move is to name the small kernel that actually differentiates the software, the core domain, and physically set it apart from the generic mass, so effort flows there by default. Maxwell's 4 equations are the anchor, an entire domain compressed until only the essential core remains, everything derivable falling away as byproduct, which, separated cleanly, becomes reusable in its own right. The chapter is the book's strategic pivot. Every earlier modeling technique was local craft. Distillation asks where in the whole to spend it. Boil the model down. Make the core small. This section explains distillation and the core domain. Not all of a model earns equal refinement. Value concentrates in the thin part that differentiates your software from everyone else's, and the rest is ballast every business carries. Distillation is that recognition applied recursively. The same separation that once produced the model now turns on the model itself, boiling off what any domain would need until only the core domain stands in relief. Maxwell's 4 equations. Open the chapter as both epigraph and pattern, an entire field compressed to its irreducible center. The operation is a gradient follower. Dried scarce talent where value is steepest, deny the generic any prominence, and let every other investment justify itself by how it serves the core. Make the core small. This section explains the large-scale structure, the 16th structural primitive. Thousands stitched the AIDS quilt independently, yet it cohered, because a shared pattern told each maker where their panel sat in the whole. That is the primitive. A large-scale structure is a coordinate system laid over the design, a language of high-level roles and rules spanning every bounded context, letting any developer place a part in the whole without reading the part. Modules chunk and distillation ranks, but neither lets you see the forest for the trees. The structure coordinates independent work by handing everyone the same map. Its governing constraint is the evolving order pattern. The structure must emerge from the design and keep shifting. Imposed up front, it becomes a straitjacket. One teams dumb their code down to fit. This section explains why modules alone do not organize a large model, and what the chapter adds on top of them. Modules chunk a large model into graspable pieces, yet a heap of well-named packages still hides the forest. You know each tree, never the shape of the wood. The chapter's move is to add an orthogonal organizing principle, a system-wide language of roles and rules that fixes each part's place in the whole without anyone needing its internals. The satellite simulator anchor makes the surprise sharp. The conceptual layers they imposed were not modules nor any code artifact at all. They were a constraint spanning every module and object, reaching even to the interfaces with foreign systems. So the layers act as a coordinate frame for meaning rather than another container. And it must evolve with the domain because an upfront frozen structure becomes a straitjacket. Less is more. An ill-fitting structure is worse than none. This section brings the 3 strategic principles together into one working method. The 3 principles, bounded context, distillation, and large-scale structure, are not a menu you choose among. They are orthogonal operators on the same design, each cutting at a different scale, so a strategy is their composition rather than a selection among them. One structure can order a model inside a single context, and at the same time order the whole context, and at the same time order the whole context map. Layering can itself be part of the core domain. The step that does the real work is this. Strategy is grown, not decreed. Assess the current situation first, then let the structure emerge from the teams doing application development, with architects acting as peers who get their hands dirty. The contrast that reveals the shape is the ivory tower architect, handing structure down before any code exists. That approach reliably fails. This section explains how the 3 strategic instruments of the chapter relate to each other, and who is entitled to set the strategy. Bounded context, distillation, and large-scale structure. act as three orthogonal axes over one design. You do not pick one and discard the others. A layer scheme can live inside a single context, span the whole context map, or differ per context. The chapter's move is compositional. It hands you the rule that these patterns stack by scope rather than store. The understated surprise sits in the second half, and it concerns who sets the strategy. Strategy must be feedback, coupled to implementation. The ivory tower architect who decrees structure without building against it is often ignored or bypassed. So effective large-scale structure emerges from the development team, through evolving order, or from an architecture team that gets its hands dirty. Uncoupled strategy decays. The setter must remain a peer of the builder,